Okay, everybody. So we're going to solve the following trigonometric equation on the domain 0 to 2 pi. And our equation is 2 cosine of x plus 4 cosine squared of x minus 2 is equal to 0. So notice that it's in the form of a quadratic here. And actually, don't let them do stuff like this to you. It it's in a form right now that's a little bit harder to work with. It would be much easier if we brought that quadratic term forward. And I can do that because order doesn't matter with addition. Additionally, I can divide everything here by 2. So this becomes 2 cosine squared of x plus the cosine of x minus 1 is equal to 0. Okay, that is a much, much easier function to work with. Now, in this particular question, there are two levels to this problem. There is an algebraic level, and then there's a trigonometric level. Okay, so I'm going to kind of rewrite this to really try to make my point here. This cosine squared really looks more like this. Okay, so what I mean to say by that is the trig function is sort of happening within the algebra here. It's what happens next. So because we're solving, I am going to deal with the algebra first, then I'm going to deal with what's inside the parentheses, then I'm going to deal with the cosine there. So in a sense here, it's normally if you were evaluating, you would follow BEDMAS, you'd do what's inside the brackets. But because I'm solving here, it's a little bit opposite. Now, for some people, it actually is going to make a huge difference. If we were just, let's replace cosine with the letter C. Let's deal with the algebra first. Okay, then we'll get to the trigonometry. So I'm going to solve for C first here. And I'm going to do this by factoring. So 2C, C. I know this has got to be 1 and 1. I'm looking for signs to work so that the product is negative, but the sum is positive. So this is going to be negative. This will be positive. So either 2C minus 1 is 0 or C plus 1 is equal to 0. So 2C is equal to 1. C is 1/2. Or over here, C is equal to negative 1. Okay, good. So I've solved the algebra part of this. Now I'm going to replace that C with the cosine of x. Okay, cosine of x. And now I'm going to solve the interior trigonometric part of this. Okay, so first of all, let's go back up. Now that we're looking at the trig here, remember that our domain was 0 to 2 pi. So it's really just a one complete rotation. Look at this first one here. Cosine of x is equal to positive 1/2. Okay, well, cosine is positive in quadrants 1 and 2. Sorry, 1 and 4. My mistake, 1 and 4. And now I need to identify, well, what angle connects the cosine to a value of 1/2. And you're probably going to have to go through in your head. You either memorize this using the unit circle or special triangle. Some people use the chart. You might even just use your calculator. But what we're going to see here is that if we're looking for the reference angle will be the inverse cosine of 1/2. That is going to be pi over 3. And in quadrant 1, that will definitely be pi over 3. And in quadrant 4, okay, going all the way around the circle, that is going to be 5 pi over 3. You might think of it like this. We're cutting up the top half into thirds, the bottom half into thirds. Here's my first quadrant. This is my fourth quadrant. That's the first trig function that I got to work with. Now I've got to work with the cosine of x is equal to negative 1. Okay, well, cosine, if we go back to our unit circle, remember that any point on our unit circle, if this is our theta here, any point on our unit circle is going to have the coordinates cosine of theta, comma, the sine of theta. And remember, we're talking about a radius of 1 if we're talking about the unit circle. So going around, the only places where the number 1 will actually show up on the points here are going to be at the extremes. Okay. That's just how this works here. So cosine and sine are the x and y coordinates of any point on the unit circle. And the only place the values of 1 show up here are going to be at these extremes. Now, cosine is associated with the x-coordinate. So as I go along the circle, remember what this is saying, I'm looking for the place where cosine becomes -1, or much specifically, where the x-coordinate is -1, and that is right here. So I know that the x value that I'm getting here corresponds to 180 degrees, but in radians, that would be pi radians. So putting my answers all together, it's either going to be pi over 3 pi or 5 pi over 3 if you put them in order.